Hi everyone, this is your lecture on energy transformation. So at this point you should have your Google Notes doc open, hopefully in another window so you can toggle back and forth between them. And remember, even though I'm going to move at a pretty quick pace, the nice thing about this video lecture is that you can pause and go back and rewatch as much as you need, and definitely use the pause feature so that you can stop and take notes in your notes document and then continue on. So energy transformations, this is what we've been looking at this week, and let's look at some definitions and some more specific examples of what we're talking about when we look at energy transformations. You have a couple objectives for this lecture. First, to be able to describe how energy is transferred between forms. Second, to be able to define and observe conservation of energy in real-life systems. And third, to identify energy conversions in typical energy systems. So we're going to do some practice today. So first of all, the law of conservation of energy, I've mentioned it in a couple videos this week. Basically, we're looking at the idea of energy in equals energy out. This law states that energy can neither be created nor destroyed. So energy does not just disappear or reappear in our system of our planet. It comes from somewhere and it's constantly being recycled. So energy just transforms from one form into another. So the forms that we've been looking at for the last couple weeks, we have to understand how they're connected and how energy moves through systems and transforms from in between each of those forms. So one really simple example to help you understand this is that electric energy converts to heat energy in a stove. So obviously the stove is not going to work unless you plug it in. And if we're talking about an electric stove, you plug it in, you turn it on, the electricity runs through the wires into the stove. The stove has heating elements that then convert that electricity into heat or thermal energy. So that's what we're talking about by energy in equals energy out. That you always have to account for the energy in a system. And so what you put in has to come out somewhere. So let's look at some of these energy transformations. Energy transformation is the process of changing energy from one form to another. So if you look at this diagram, we have the sun's energy hitting solar panels, which creates electricity, which then lights the light. So energy transformations happen because matter moves, atoms can move, particles move, and that allows energy to flow through a system. If you've ever looked at one of those, they call them Newton's cradles. They're the silver balls that are hanging in a row, and when you pull the one back and let it go, the energy transfers through the other balls and makes the one at the opposite end jump out, swing out. So that's what we're talking about. If you think of that as how energy is transferred, it'll give you a good mental picture of what we're talking about in these kinds of transformations. So energy is converted between forms. So let's think about it. We have solar energy here being converted to electrical energy here, then being converted to light energy here. That's an example of a transformation. So to review what we know about energy so far, we know that we have two basic types of energy. Okay, we have potential energy and kinetic energy. So what's our definition of potential energy? It is energy that is stored. And we have four forms of potential energy that we have talked about and worked with over the last couple weeks. The first one is gravitational potential energy. You know, if something can fall, it has stored energy in its position. So if you can fall, then you have gravitational potential energy. Something that can be stretched or compressed and then sort of bounces back to its original form, that is elastic potential energy. We have chemical potential energy that is stored in things like food or batteries, where the chemicals hold the energy in their bonds. And then we have nuclear potential energy, which is the energy that is stored in the nucleus of an atom. And when you break this nucleus apart, a lot of energy is released. So let's look at the other type that we talked about last week. That is kinetic energy. So kinetic energy is the energy of motion. So when things are in motion, we have kinetic energy. So energy is either stored or it's in motion. And the four forms of kinetic energy that we've talked about are light, which is also called radiant energy, electrical energy, thermal or heat energy, and sound energy. If you need to pause, make sure that you're recording all of these things in your notes document. So here it is in visual form. We have potential energy. It is either gravitational, nuclear, elastic, or chemical potential energy. And when we're talking about kinetic energy, we talked about light, electricity, sound, and thermal. I also threw this mechanical in here. Mechanical energy can sometimes confuse us, but when we talk about, let's say, the wind, that is just the movement of air particles. So that is mechanical energy. That's also a form of kinetic energy. So let's look at each of these types, or each of these forms of energy as we talk about. So thermal energy first. Thermal energy is also referred to as heat energy, and the total energy of atoms and molecules that are constantly in motion make up heat energy. Okay? So molecules are always moving. Molecules that move faster create more heat. So some examples are the burner on a stovetop. When it's turned on, you can see it's hot. That is radiating thermal or heat energy. A hot cup of cocoa or coffee is radiating energy. You can see the steam coming off of there. And also fire is a good example of thermal energy. So at this point, when we have these try it slides, this is where you'll want to pause. So I'm going to show you some energy descriptions, and I want you to see if you can fill in the flow of the energy, the form of energy. So if we look at this candle, we see that we start with the wax and the wick as fuel. So I want to know what type of energy, what form of energy would that be? I'll give you a clue. It's one of the types of potential energy. What kind of potential energy is stored in the wax and the wick as fuel? And then when we light this, we have a burning wick. So what form of energy is that? And then that burning, that fire, creates light. What form of energy is the light that we see? So you'll pause right now and see if you can tell me what form of energy each one of these consists of. So here are your answers. The wax and the wick is fuel. That's stored chemical potential energy. The burning wick is thermal energy, and light is radiant energy. So I hope you got those three correct. Let's talk about radiant energy. This is also referred to as solar or light energy. Energy that's caused by the movement of electromagnetic waves. So some examples are the light emitted by light bulbs, the sun, and microwaves. So let's try these energy transformations. Here we have the sun as our initial source of energy, and then we have photosynthesis in the green plants, and then we have our deer that is eating the food. So let's see if you can pause and tell me what forms of energy these three things represent. So here are answers. The sun is radiant energy, photosynthesis is chemical potential energy, and then stored in the food for the deer is also chemical potential energy. And so the deer would eat that, and then if he uses it to run, then that would be turning into kinetic energy. Let's take a quick look at sound energy. This is energy in the form of wave motion. So if you can picture what sound looks like, it actually moves air molecules like this in the form of waves. Vibrations spread in all directions as one vibrating object touches another, causing it to vibrate. So like a drum, a tuning fork, or talking. Those are all forms of sound energy. So let's see if you can follow the energy flow. We start with the sun, and then it hits the solar panel, into the wires, into the radio that creates music. So pause and see if you can identify the forms of energy. So the sun is solar energy. The solar panel creates electrical energy. which sends through the wires in the form of electrical energy, which powers the radio, which music is sound energy. So hopefully you got those answers correct. Electrical energy is moving electrons from one point to another in a conductor. So a wire is an energy conductor, and electrons can move through there, and it creates an electrical field. So some examples are electric current in wires or lightning. That is when the particles move through the air in the atmosphere. So those are examples of electrical energy. Let's see if you can follow this energy flow. It's a short one. So we have the lightning here hitting trees, and we have the trees burning. So take a pause and see if you can identify those forms. So lightning is electrical energy, and the fire converted it to thermal energy. So we're going to see heat. And we can also say that maybe we have some light, which would be radiant energy, because this fire is going to give off a lot of light. So let's look at chemical potential energy. It's energy stored in chemical substances. So fuel of a fire, there is energy stored in the wood here. There is energy stored in explosives, in the food that we eat, and also in batteries. Those are all forms of chemical potential energy. See if you can follow the energy flow here. We have from a battery through the wires, electricity, and the light. So what forms of energy do those take? So a battery is chemical potential energy, electricity is electrical energy, and the light that's produced from the light bulb is radiant energy. Our final one, nuclear potential energy. It's also known as atomic energy. So that's the energy that's stored in the nucleus of an atom. So it can be released by fusion, either combining atoms' nucleus, or fission, splitting an atom's nuclei. So nuclear power plants are a good example of fission, and the sun is a good example of fusion. So let's see if you can finish this final example here. Fusion in the nuclear reactor, and then it turns the turbine, and then we have the generator and wires. So we have our nuclear reactor, the turbine and the generator, and the wires. So the fusion at the power plant is nuclear potential energy. Turning the turbine and the generator is kinetic energy. And then in the generator and the wires, we have electrical energy. So that was a quick overview of the different forms of energy and how we convert in between them. So at the end of this, please make sure that you can describe how energy is transferred between forms. You can define and observe conservation of energy in real-life systems, and you can identify energy conversions in typical energy systems. If you need to rewind, go back in this video and complete any notes that you might have missed, but definitely use these notes to take your end of the week quiz today. Be sure to click submit on the Google form and turn it in on your Google Notes doc. And please see me if you have any questions. Thanks for watching.